Hey, what's up guys? Back again with another video in the C++ series. This time we're going to continue learning about pointers, and we're going to start off learning about null pointers, which are basically pointers that point to nothing. So let's get right into it. So what we have, well, sometimes whenever you make a variable, like let's say we have an integer here, integer Bob, and let's say whenever we create it, we don't initialize it, we just leave it like that. So we declare it, but we don't initialize it. So then later on, we then initialize it with the value of 134. So if we don't initialize it, what happens if we print this out? So see out Bob. There we go. Let's see what that prints out. Even though we didn't give it a value, let's see if it has a value. And no, we get a problem here. It says debug error, runtime, check failure. The variable Bob is being used without being initialized. So that's a problem. So it's very recommended, of course, that you just put a 0 just like that. There you go, and that will fix that problem for you. And so if you run this now, obviously it's going to print out 0. Good, so we get 0. So that's all fine and dandy, but let's look at what happens when we do that with a pointer. So let's say we create a pointer to this integer here. Let's change this to 156. Let's create a pointer. So integer is the data type of the pointer. Well, not the data type of the pointer. The data type of the pointer is obviously a memory address. But what does the pointer point to is what I mean by that. If you don't know what pointers are, obviously just watch my last episode. I went into great detail about pointers. So this is a pointer to an integer, and we'll call this Bob pointer. And it's going to be equal to nothing. We're just going to leave it uninitialized. And let's see what happens when we try printing out Mr. Bob pointer here. So let's run this. And we get a problem here. It says debug error, runtime, check failure. The variable Bob pointer is being used without being initialized. So it's the same thing. You don't want to initialize a pointer if without a value, because then that's a problem, obviously. But why is that a problem? More specifically, obviously you can't print out something that doesn't exist, but actually whenever you create a pointer and you don't assign it an initial value like a memory address of, for example, if you don't give it the initial memory address of Bob, then what's going to happen is this pointer is going to be created inside of your memory, but at the same time it's going to be given a garbage memory address, which is just a random memory address that that is assigned to this pointer location, basically. And you don't know what could be in that memory address. It could be anything. It could be anything really, right? So if you don't know what it is, you obviously don't want to mess with it. You could break something, and that can get very dangerous. So we'll talk about that actually later in the video when we get into arrays and stuff like that. But basically what you want to do is, if you for some reason you don't initialize the pointer right away, it's a very good practice to initialize it as a null pointer, which just tells you as the programmer that it's not pointing to anything currently, and it also tells the compiler that it's basically it sets it the memory address of 0, so that if you were to accidentally try and change that pointer and you didn't realize it, you wouldn't be doing anything crazy. You would just be trying to change a dummy memory address. So let me show you what I mean by that. So there's 3 things you can do. You can either do 0, and that will basically set it to the memory address of 0. You could also do null, which is just translated into 0 behind the scenes. But then also in one of the newer versions of C++, you also have this one, null PTR, for null pointer. And all of these do the same thing. They all translate to 0. So what that means is that basically you're going to be assigned, this pointer is going to be assigned the memory address of 0, and nothing's there. So if you mess with it by accident, then nothing bad is going to happen. So that's good. So let's try printing this out to see what happens when we try and print out a null pointer. There we go, we get the address of 000000, which is exactly what we expected, because this is translated into the 0 memory address. So let's try one of these other ones, see what happens when we try maybe null. Like I said, you can use all 3, it doesn't really matter. But in a second, I'll tell you something. Hold on, let's see what this prints out. And yeah, we get 000, so that's good. The compiler is able to recognize that you're using the null memory address. But something that you need to know is that it's actually recommended that you use this one here, not the other ones, because I don't know the exact reasons. I guess there's a couple of them, but one of the main ones I've seen is that, and you could do more research on this if you really care, but 0 is obviously an integer, and you're basically trying to assign an integer to as the memory address, which is you're not really supposed to do that. Obviously the compiler knows that this is just a null memory address, but if you use null, this is also an integer, right? But if you use a null pointer, that's not an integer behind the scenes. This is literally just a keyword itself. As you can see, it's dark blue because the IDE recognizes this is a keyword, not an actual integer. So it's just, I think it's better. And there's also some other reasons, like I said, so if you look more into that. So I just recommend use this one, null PTR. And there's actually a fourth one too. I think it's this one, avoid, whatever. And this is good for certain circumstances, but yeah. Maybe I'll leave a link in the description for this if you're interested. And yeah, that's how you do null pointers. Basically, just to recap, if you are not going to initialize a pointer right away after you create it, then go ahead and set it to a dummy value null pointer 0, so that if you were to do some changes to it or print it out or something like that, you wouldn't get any issues. Okay. So yeah, that's how you do that. And now let's move on to arrays. How can we make pointers to arrays, and then how can we use arrays with pointers, basically? So let's talk about that a little bit. So pointers to arrays. So I'm not sure if I've gone over this, maybe you noticed it in your programs, but let's say we have an array here, so double scores. So this is an array of scores with some random values, and we'll give it some random scores here. Okay, that's good enough. That's a really big score, the last one, but so if you've ever tried printing out an array, the name of the array, so scores, you might have noticed that something a little weird happens. So I mean, if you're not experienced with programming or anything like that, you're gonna probably think that this just prints out all of the values of the array, but that doesn't happen. When you print out the array here, you actually get this weird looking thing, which is a memory address. If you watched last episode, you'll recognize that that is a memory address. So the reason it's doing that is because the array is a collection or like a grouping of different variables together. Of course, we're not making variables here; they're just numbers. And basically, whenever you create this array, inside of your memory, you're going to be allocating 1, 2, 3, 4, 5 consecutive spots, and that's a double. So basically, 8 times 5, 40. You're going to be allocating 40 bytes of space right next to each other, all together, of memory for this double array here. And so basically, this memory address here stores the starting memory address of the first element in the array. So, like I said, you can imagine your memory, whenever you create this array here, you can imagine it being allocated like this, so 1, 2, 3, 4, 5. So in your memory, you're going to have 5 slots, 8 bytes each, allocated, and the address of the array itself will be the first address of the first one, so that whenever you're messing around with this array, the compiler knows where to begin looking for the values of this array. And then also behind the scenes, the compiler knows how big the array is, so it knows it's supposed to go on for 4 more values, so 5 total. But this is an issue for us as the programmer. We're not the compiler or whatever, so we don't know. I mean, we know, but basically, well, you'll see in a second what I'm trying to say. But just know that a array here, basically, if you print it out, prints out the memory address of the first element in the array, and we can work with that. So if you remember last episode, how do you get the address of a variable? You would put the ampersand in front of it, and you can actually still do that if you want to, but there's really no point, obviously, because if you print it out by itself, it's automatically going to print out the address of that location. Okay, so let's say for some reason we want to make a pointer to this array here. How would we do that? So since a array by itself, when you print it out, has the memory address of the first element, basically you're going to create a pointer to that first element. Alright, so let's try doing that. So we'll make a pointer to a double, because this is an array of doubles, and we're going to give it a name here. So we're going to call this pointer to scores, and we're going to initialize it as scores, just like that. So what that is going to do is basically set the memory address of the first element in this array here equal to this pointer that we have here. So this pointer will store that first memory address. So let's try printing that out now. So cout pointer to scores, and what this is going to print out is the memory address of the first element of the array, and we can put that. Let's try printing out the memory address of the first element of the array from the array. So we'll do cout scores just like that, and then we'll also print out cout pointer to scores, and those values should be the same because they are both storing the same thing. So let's see what happens. There we go. So we get 00CFF894, and then the same thing for the second one. Good. So we know our pointer is actually pointing to the first element in the array now, which is good. But we can also print it out, of course. Just dereference it. Not like that. I mean like this. So dereference it by putting the indirection operator in front of it, the asterisk. And you can do the same thing for this one, I think, right? So let's see what happens when we do that. There we go. So yeah, we get both the same value, and that's pretty interesting. So, you could put the indirection operator in front of an array, and that's going to return the first value in the array, because of course this is you can think of this as a pointer of its own. I don't think an array is a pointer, but you can think of it as a pointer technically, and then of course you're just dereferencing it, and then we're doing it down here again for this pointer that we just created, and so we're dereferencing the first element. Okay, so let's think about. But it gets a little more complicated here. So let's say that we want to print out these other values in the array, because of course it's an array, it has multiple values, so what's the use in just printing out the first one? Why would you want to store only the first one, right? So let's think about how do we get those other values? And like I said before, they're all stored consecutively. They're not all in random spots. They're all next to each other in the memory. So if you have the memory address in this pointer here, let me get rid of this. If you have the memory address of this pointer here pointing to the first memory address of the starting address of the array, basically, if you were to go to the next 8 bytes of that memory address, then you would come to the next value. If you were to add if you were to add 16 bytes to that memory address to the first one, you get the third value, and so on. So since they're all next to each other, we can use that to our advantage, basically, by getting the adjacent value by adding or subtracting a pointer. And you can actually do that. You can add or subtract to pointers, which will in turn go to the whatever value. So let me show you. So let's do cout first double of the array. So we'll try printing that out. So how do we print out the first double of the array? We can just use the scores thing here, because of course it's already automatically pointing to the first value of the array. So then we'll do second double of the array. So how do we get the second double of the array? Well, you can actually do this here, so scores plus 1 and inline. So let me explain what this is. So scores is going to be a memory address, and you're going to add 1 to that memory address. So what it's going to do is it's going to automatically recognize that you're trying to add one value onto that memory address. And it's not going to add the number 1, it's going to add one memory space, one chunk of memory. So what I mean by that is, of course, this pointer points to a double, right? So it's going to automatically recognize that one memory space is equal to 8 bytes for a double. So it's going to add 8 bytes onto this memory address that we have here. And then after it does that, it's then going to dereference that new memory address just like that. So basically, also you need to have the parentheses here, because order of operation. So if we were to remove this, let's see what happens. So if we were to remove this, then it would dereference the first, just the pointer itself, and then it would add 1. So basically what it would do is it would get the value of 45.4 and then add 1 to that, so 46.4, and then it would print that out. So before we do the dereferencing, we want to add one space of memory, one chunk of double 8 bytes, to the memory. Hopefully that made sense. But yeah, that's what that's going to do. So let's try printing. Let's fix this. But let's try printing this out now, and we should see the value of 100 also behind this one. So yeah, we get 45.4, and then also we get 100. Perfect. And let me get rid of this so I can demonstrate to you what actually happens when we do that. So we should get 46.4, and yeah, we did. We get 45.4 because we're just printing out the pointer by itself, dereferencing it. But then we're dereferencing it and then adding 1 after that. So then we get 46.4. So again, just add the parentheses here, and you'll be good to go on that. So let's say we want to add the third one, just for more practice here. So to add the third one, we would do the third double of the array. So dereference scores plus 2. So what is that going to do? So that is going to add it recognizes that it's a double, right? So that's going to be a total of 16 bytes. So it's going to add, basically it's going to go to the next 16 bytes, or it's going to skip 16 bytes over basically, and then get to, the third location, which is going to be 95.4. So it's going to dereference that memory address and then get 95.4 and print it out. Easy peasy, right? So just don't forget, it's a really simple concept, but just don't forget, in case you're confused here, that this is not adding 1, it's going to add 1 chunk of memory, which happens to be a double because it's a pointer to a double, which is 8 bytes. So then we get in the console, the third double of the array is 95.4, exactly what we wanted. So C++ actually has another way of accessing the array values of a pointer. So let's say we want to print out the fifth and final value of the array here, so fifth double of the array, and we're going to be using the pointer for that, not the actual array. So before we would have had to do scores plus 4, right? That would give us the fifth value, because if you start at 1 and then add 4, you get to 5, right? So we would have had to do that before, but with this new syntax, I think this was introduced in one of the newer versions, I might be wrong, but you can do pointer to scores and then just do it with an index in the brackets. So if it's the fifth one, it would be the fourth index, right? So basically, C++ makes it even easier for you by letting you do the syntax that you would do with a normal accessing an array. You can also do that with a pointer to an array if you know that this pointer actually points to an array, okay? So that's pretty cool. So did I print this out? No, I didn't. So let's run this now and see if it prints out the fifth value here, so 144. And we get fifth double of the array is 144, perfect. So yeah, so like I said, you can add and subtract values from memory addresses and pointers and stuff. So that's what we're doing here. We're adding values, so we can also subtract values if we want to. So basically, let's say we were to do double this, or not, we don't want to make a new one. We want to do pointer to scores is equal to, and then we could actually just do pointer to scores plus plus. So we're adding one memory address to the current memory address and then setting it equal to our pointer here. So this should basically change the value, reassign our pointer here to use the memory address that's directly after the first memory address. So we should, if we were to print this out right now, we should probably get 100. If the first one was initially the first one here, then if we were to go plus plus, which is plus 1, then it should go to the second one here. So let's try printing this out. We'll just do it like this. So cout value, and we should get pointer to scores, just like that. And of course we want to dereference it, or else it would print out the memory address itself. So let's see what we get. So yeah, we get value 45.4, which is not correct because we reassigned it. So it should be 100.0, which is interesting. Oh, that's why. Of course, you don't have to, if you're doing pointer to scores plus plus, you don't need to actually do the equals and all that. That itself is going to reassign it to the second value. So that would be the same thing as doing integer bob is equal to 24, and then doing bob is equal to bob plus plus. That doesn't make sense. You would just do bob plus plus by itself. So oopsie daisy. And so that should do that for us now. So we should this time get 100 into the console. And yeah, we got 100, perfect. So yeah, like I said, you can add and subtract values. So if you were to go back down here under this one, let's just copy this here. If you were to do minus minus, then we should get, again, we should get 45.4. Yeah, we do. We get 45.4. Perfect. Pretty cool. And that's how you add and subtract values. So think about this. What would happen if you were to do this? Let's say we did this. So pointer to scores is equal to pointer to scores minus 5. So we get 100, and then we just get a crazy value after that. So why do we get this random value here? That is because we're going outside of our array here. So in our array, we have 5 consecutive values that we can access, right? And so we're accessing them fine right here, we're accessing it fine right here, but then we're doing minus 5. So if the initial value is right here, and then right here we're doing plus plus, so we're right here right now. If we were to go five spaces beyond that, we're way out of the scope of this array here. So we're going to be reassigning our pointer to a random chunk of memory that we have no idea what it is. It could have anything, and obviously it does have something random here. 3.62969E plus 289 is a really big number, obviously. So that's kind of dangerous. You don't want to be accessing memory that you have no idea what it is. So it's very wise for you to keep track of how big your array is and then stay within the size of that array, because if you were to go beyond that, let's say if we were to accidentally put 100 here, obviously our array is definitely not 100. So we were to add 100, 8 times. If we were to add 800 bytes onto that, that would be a problem. So let's see what happens when we do that. Let's see what actually prints out, if it has anything. So we get the third double of the array is 0. Okay, that's interesting. Maybe there's nothing there yet or something. I don't know. But yeah, the point is the point behind that is that you just want to be careful. You don't want to access memory that you have no idea what could actually be there. You want to access memory that you know has something of value to you and that you can work with and you have worked with before or something like that. So yeah, just be aware of that. It's kind of dangerous. And if I think there's actually a way for you to access memory that is very vital to the computer itself. Actually, I think there's systems in the computer that prevent you from like safety systems that prevent you from accessing vital memory, like stuff that would keep your system, the main program of your system running. I think there's systems in place to keep you from accessing that, or else that would be disastrous. So I don't know, maybe you should play around with that, see what happens, if you can blue screen your computer or something. Let's stay away from that for now. But yeah, so that's good. That's how you access arrays and then create a pointer to an array. Again, just to recap, you're basically just setting it to making a pointer to the first value of that array, and then behind the scenes you want to keep track either in your head or in a variable how big that array is. Okay, so let's give you one more example. So like I said, you want to keep track of how big the array is. So a good thing you might do sometimes is just make a constant up here. So constant integer max size is equal to 5. And then whenever you're declaring the array, of course you can just pass in the max size. You don't really need to, because you're explicitly saying how big it is. But whenever let's say we were to loop through that entire array here, so int I is equal to 0, oops, and then I is less than max size, and then I plus plus. And then for each iteration, what we want to do is do cout value I, and then pointer to scores I, just like that. So basically we're just printing out each value in the array with this pointer here, and then looping through it, of course. So let's try running this, see what we get. There we go. So we get I think this is just, I might be wrong, wait, I think this is the reason it's doing this, by the way. It's just my thing here glitching or something. I don't know why it's doing that, but yeah, we do get the values though, which is good. It's able to loop through the entire array here and then print them out from the pointer. But notice that we're using the max size constant here, which is very safe, because no matter what, we know that the array here is also following this size here. So if the array here has the same size as the amount of times that you're looping, then obviously you're going to be really safe. You're not going to go beyond the bounds of the array that you've created. So you're not going to be accessing, the memory. You might, you don't want to mess anything up, right? So that's very safe. That's a very safe thing to do. So maybe you should do that in the future whenever you make programs. Make it constant or something like that to keep track of it safely. Alright, so that's pretty much it. Pointers to arrays and all that. And then, accessing it and being careful and stuff. So a second ago I showed you that you can do arithmetic operations on pointers. You can add and subtract them. You can even multiply them, I believe. I never actually tried that, but you can do that if you want to, I'm sure. But we can also do comparing. So what I mean by comparing is, less than, greater than, and all that stuff. So we can do that. So let's create an array here for us to work with here. So we'll make a string of presidents. Array of strings of presidents. So we'll start off with Richard Nixon, Ronald Reagan, Donald Trump. Let's think here, Abraham Lincoln, of course. And let's think of one more. Oh yeah, my favorite president. Let's see. Yeah, he's my favorite. So yeah, these are our 5 presidents here. And let's try comparing them. So we're going to make a pointer to the first value of this array here. So we'll make a pointer, so string, so it's a pointer to a string, and technically a string is not a primitive value, it's an object, and you can actually make pointers to objects, which is mostly what you're going to be using pointers for, and you'll see that later on. Pretty cool. And anyway, so we'll say pointer to presidents, pointer to president, that's good. And that's going to be equal to precedence. So that's going to set this pointer here equal to the first memory address of the array. Pretty cool. And now let's print out, just for testing purposes, the first president in our array so we can know that this worked or not. So we'll do dereference pointers to presidents. So that should print out Richard Nixon if we're lucky. So let's run this. And boom, we get Richard Nixon, perfect. And now let's try comparing these values. So let's say we have a pointer here. We do have a pointer here, obviously, but let's say we have an if statement here. We have an if statement that says pointer to presidents is less than, and now we'll do pointers to presidents plus 1. And just because of order of operations and all that, we'll do this in parentheses. So theoretically, if my calculations are correct, what this should do is basically this is going to point to the first one here. This is just a memory address because it is a pointer, right? So we have a pointer here. But this one is also going to have a pointer, or this is basically, think of this as returning a memory address, and then think of this one as also returning a memory address. So the first one plus 1. So this should be the memory address of Ronald Reagan, but this one should be the memory address of Richard Nixon. And so what you're doing here is comparing to see if the memory address of Richard Nixon is less than the memory address of Ronald Reagan. And let's see which one of these, if it's true or false. So we'll say true, else false. And now we'll run this here. So and we get true. Interesting. So what this means is that the memory address of Richard Nixon is smaller than the memory address of Ronald Reagan. So the question you may ask now is, how do you know if a memory address is bigger or smaller than another memory address, or even equal to? That's just in what order it comes. So if a memory address comes after another memory address, that means it's bigger than that other memory address. So for example, the memory address of Donald Trump would be way bigger, or not way bigger, it would be bigger than Ronald Reagan. And Ronald Reagan would be bigger than Richard Nixon, but Donald Trump is not bigger than Abraham Lincoln or Cody Simpson. These are bigger than Donald Trump. So just basically whichever memory address comes after is bigger. Alright? So if we were to change this to greater than, that means that Richard Nixon is greater than Ronald Reagan, but Ronald Reagan comes after in the array, it comes after Richard Nixon, so it's going to have a bigger memory address. So it should print out false because that's not true. Richard Nixon has a smaller memory address than Ronald Reagan, and we do get false perfect. So let's do another example, instead using another operator, a comparison operator like the equal sign maybe. So we'll say if the memory address of pointers to presidents 2, which is the third one, is equal to the memory address, where is it? There we go. The memory address of pointers to president 2. So these are the same memory address, obviously, which will be Donald Trump in this case. So if this is the same memory address on both sides of the equal sign, we should get whatever is inside of here. Alright, and then otherwise, nah. And of course these will obviously be equal because they're literally the same thing. So they're both the same memory address, so let's run this now, see what happens. And yeah, we get false, and then Cody's awesome, which is what is run when we get this here. And let's see, what does it say? Condition is always true. Okay, that doesn't matter, but let's just do one more example finally. So we'll say if the memory address of pointers to presidents 2 is equal to the memory address of pointers to president 3. So this will obviously be false because the memory address of Donald Trump is not the same as the memory address of Abraham Lincoln. So yeah, we get nah. So yeah, that's how you compare memory addresses. And believe it or not, this is actually kind of useful. I've seen this in a few programs, comparing memory addresses. So this is good to know. And yeah, that's about it for this episode actually. So I showed you how to do proper initialization with null pointers if you're not going to be initializing the value right away. And then I showed you how to do pointers to arrays and how to safely access them and all that. And then finally, I showed you how to compare pointers, compare memory addresses. So that's going to be kind of useful for you. All of it's very useful. So yeah, that's about it for this episode. Hopefully you enjoyed it. If you have any questions about what I showed you today, you can ask in the comment section below, or you can join our Discord server. We have a big Discord community with about close to 1,000 members, which is kind of crazy. A bunch of developers in there in case you need any cool developer friends, or you can join to get help if you need any help on anything. You can ask questions there. We have a bunch of help channels, and then also you can leave suggestions for future videos if you want to. So yeah, join the community. There's a link in that for the description below. And yeah, all of the code, do not forget, all of the code for this episode is all in the description below. So you're going to get a piece of code from my website like this, and it's going to have all these comments next to it, so you can see all the explanations in case you forget any of the concepts or you do not understand them while watching today. So make sure you click this link and then bookmark it for the future in case you forget how pointers to arrays actually work, okay? So that's about it for that. If you like this video, leave a like. If you want to see more, subscribe, and peace.